Hi everyone, welcome to this video. This is the last type of rational function. Okay, so we have come across reciprocal functions, and we have also come across rational functions that look like this, what I have here, right? 2 over x plus 2, and we know how to find the vertical and horizontal asymptotes for both reciprocal function and a rational function that looks like this. Now in this video, I'm gonna go over the last type. Okay, so the last type of rational functions is in this form. So y equals to, in the numerator, I'm gonna have some ax plus b, almost like a linear function, right? And my denominator, I'm gonna have cx plus d, another linear function kind of. Right? So my a, b, c, d, they will just be values. They will be any real number. Okay. So the first scenario that we are going to analyze is when my a is less than my c. Okay? So if you look at my equation over here, what's my c over here? What's my c for this? Y equals 2 over x plus 2. My c is 1. Right? In this case, my c equals to 1. There's 1x here. What about my a? I have no x in the numerator, so my a is equal to 0. Does that make sense? Let me type that down. So my a is equal to 0, and my c is equal to 1. Okay? And that will give us this expression right there. And of course, I'm going to have some b. In this case, my b is 2, and my d is also 2. But for now, I'm only going to focus on my a and my c. We call them the leading coefficient. The leading coefficient. They are the coefficients are the numbers in front of your variables. And right now, I have a being 0 and c being 1. So, let me ask you guys, what are the asymptotes of this equation? My horizontal asymptote, where would it be? My vertical asymptote, where would it be? You should know how to find them by now. So if I show the graph, my vertical asymptote would be at -2. Okay? I'm going to have a vertical asymptote at -2, and my horizontal asymptote would be 0. So there you go. My horizontal asymptote over here, my horizontal asymptote here, my vertical asymptote there. Okay. Now, I'm going to change the condition now. I'm going to change this. So let's see today, what if a is equal to c? Okay, let me hide the asymptotes and the graphs. If I have a equals to c, so let's say something like say 2x. Let's just make it interesting. 2x, and I will have 2x as well. I can change that to 1 just for fun. So in this case, my a is equal to 2. My c is also equal to 2. Now, where are my asymptotes gonna be? You should be able to find out where the vertical asymptote is, because vertical asymptotes connects to my domain, and my domain is where my x values can be. My x values can be anything, but whatever value that makes the denominator 0, that's where my x cannot be. Right? So if I solve for this, if I say, let me just show this to you guys. 2x plus 1 equals to 0. If I solve for this, when my x is negative half, that's when this is going to come true, which means my vertical asymptote will be at x is equal to negative half. Alright, so we should know how to find the vertical asymptotes now, simply by taking the denominator, and because when x is equal to negative 2, when I put in here, my whole denominator becomes 0, and that's not good. Right? That's not good. I cannot have denominator as 0. Therefore, my x can be any value except negative half, and that is where my vertical asymptote is going to be. So write this line right here. What about my horizontal asymptote? So we have never tried to find the horizontal asymptote where you have some x on the top. Right? You have some coefficient with the x in the numerator. So for now, let's just take a look at the graph. So this graph right here, this is my the graph of my y, where my y equation is 2x over 2x plus 1. So it seems like I have a horizontal asymptote over here, right, at 1. So let's try to change that. So my y is equal to 1, and let's show it. And let's zoom out, and it seems like that's pretty accurate. Right? So that's where my horizontal asymptote is. Now, is there another way? Is there another way to find this 1 just from the equation? So for now, it seems like perhaps this 1 is from this plus 1, maybe. So let's say if I change this, right? If I change this to say negative 3, then maybe my y is gonna be at negative 3, maybe, maybe not. We'll see. But if not, then we know this negative minus 3, whatever value there is there, it does not really affect my horizontal asymptote. But we'll see. But for now, what's for sure is this will definitely change my vertical asymptote. So my vertical asymptote is no longer going to be there, but we know how to find it. For now, let's just focus on the horizontal asymptote, okay? So I'm saying that maybe this is the value that played a role determining where my horizontal asymptote is. So I'm just going to show that and say, okay, I'm going to guess that my horizontal asymptote is there. And apparently not. Right, my horizontal asymptote is still there. It is still at 1. My horizontal asymptote is still at 1. Not the negative 3 we have there. So what happens actually here is by changing this negative 3, we are actually changing my changing my vertical asymptote. So that's not good because I already know how to find the vertical asymptote. So let's not change that. So let's change it back to plus 1. My vertical asymptote is still there. Now, then we just confirmed that adding this 1, that plus 1 has nothing to do with my horizontal asymptote. So what else can we do? Then maybe, perhaps, I see that I have a 2 here and a 2 there. So if I take my A divided by my C, which is 2 over 2 for now, maybe that's how I get my horizontal asymptote, just from looking at the equation. Maybe, right? So I'm going to try out with this scenario, this approach. So if I'm correct, then I'm gonna change this to say 3, and I'll change this to 3, and let's see if my horizontal asymptote is gonna be at 3 over 3. Just to be sure, because I have changed this 3 over here, the denominator is now 3x plus 1. If I solve, my vertical asymptote is not going to be changed because of this, and my vertical asymptote will be at negative 1 over 3. So my vertical asymptote is here, and seems like my horizontal asymptote is gonna be, let's see if it's right, hopefully it's right. For now it looks like it's at 1, right? For now, if you look at the graph, it looks like the horizontal asymptote is at 1. Let's show it, and it is at 1. See, if I go towards the right, it might look like it's touching, but there is actually some gap between them. If I go to the left, I can zoom in, zoom in, zoom in. You can see that there is some gap there. So there you go. So here we have just figured out how to find the horizontal asymptote when you have linear expression on the top, on the numerator, and another linear expression in the denominator. What we do is we just take the leading coefficient and then just divide them. Okay, now the last scenario. So let's hide them all. What if my A is greater than my C? If my A is greater than my C. So maybe something like, if my A is say 6, and let's say 6 over 2x minus 1. Let's just try that. Okay, so my A in this case is 6. That's my A over here. My C in this case is 2, so that's good. Let's figure out the vertical asymptote first. So for vertical asymptote, I need to solve this. 2x minus 1 equals to 0. Decimals, they automatically give you the value, but you know, you have to do this by yourself. So bring the negative 1 to the other side. I will have 2x equal to 1. Divide by 2, so my x equals to 1 over 2. And I'm pretty confident that you guys can do this. So when x is equal to half, my denominator becomes 0. When my denominator becomes 0, the whole expression would be a problem, undefined. So my x can be whatever except half. So that makes sense, right? That makes sense. Okay, so now let's look at my horizontal asymptote. If what we figured out just now with this, taking the leading coefficient on the top divided by the leading coefficient at the bottom, if that works, then that would be awesome. So I'm going to put the 6 there, and that would be 2, right? The leading coefficient is 6, so that's why the 6 there. The leading coefficient is 2, that's why the 2 there. And I hope it's correct, because just now we did some experiments and this seemed to work. And if this pattern continues, then it will be awesome. So now let's take a look. So for now, looks like the vertical asymptote is good, and we are already very confident with finding vertical asymptote. We just have to pay attention to my denominator. And as for my horizontal asymptote, looks good too, because as I go to the right, it gets close, but it doesn't touch. It will never touch. And if I go to the left, same. It gets close, but it does not touch. So both my horizontal asymptote and my vertical asymptote, they are both good. Now, you might be wondering, what does the b do? So let's give it a try. If I add a plus, say plus 3, does the graph changed, right? The graph did change, but did my horizontal or vertical asymptote, does it make a difference? So this is without the 3, this is with the 3. my horizontal asymptote, my vertical asymptote, they stay the same.